Hey guys, hope everything is going well. We're going to cover 7-2 part 2 today, so hopefully you've done 7-2 part 1 and you've done your homework as well. And hopefully you're at the last half of the week. Remember, everything for 7-2 is due Thursday night, midnight, so please keep that in mind as you're doing big ideas. I know you guys have to prioritize. Hopefully you guys are getting back into the swing of things, but please do make a note, make an agenda, something to make sure you know Thursday at midnight's the cutoff day. All right, so 7-2, we're going to move on. Remember, day 1, we did graphing rational functions, and we kind of sort of talked about asymptotes, left, right, up, or down, but that's when it was written in what I would call a nice form. So today we're going to talk about what happens if it is not written in a nice form. So if we're looking at a form something like this, it makes life a little bit harder, okay? So when we're looking at something like this, to find the vertical asymptote, we would solve when the denominator is equal to 0. Okay, so when cx plus d is equal to 0, we have a horizontal asymptote, or a vertical asymptote, I'm sorry. That means, remember, we can never have 0 in the denominator, so when this is equal to 0, we can't have that x value, which is why we would have a vertical asymptote, up and down. We cannot use that x value. Horizontal asymptote can be found by taking the ratio of A to C, okay, and that'll be our y equals, so that'll be our horizontal asymptote. And then from the asymptote, it's about plugging in numbers and then drawing the graph. Asymptotes are the biggest thing. All right, so let's do an example. We want to find the graph f of x equals 2x plus 1 over x minus 3. We want to state the domain and range, which is pretty easy. And then we will also graph it, but because it doesn't say it, we're going to cheat. We're just going to graph it on our calculator. Actually, we'll just graph it, kind of eyeball it. All right, so here's my axis. So first thing I always want to do is I want to find my asymptotes. All right, so if I want to find my vertical asymptote, remember my vertical asymptote is when the denominator equals to 0. So I could say x minus 3 is equal to 0. Solve for x, I get x equals 3. Okay, so this is my vertical asymptote. Okay, vertical asymptote. So x equals 3, 1, 2, 3. Here's my vertical asymptote. That's supposed to be a dotted line, can't really tell. Okay, now we want to find my horizontal asymptote. Now remember, horizontal is my A over C, so my ratio of this. Now remember, when nothing is in front of the x, we think of it as a 1. So my horizontal asymptote is when y equals 2 over 1, or just when y equals 2. This is my horizontal asymptote. So y equals 2, 1, 2. This is my horizontal asymptote. Okay, now if I wanted to graph it on my calculator, I can. If I wanted to get plot points, I'm just going to make this short and sweet. It would look something like this and that. That would be your approximate graph. The domain and range, guys, these come straight from your asymptotes. So my domain, what can x not equal? Well, x can't equal 3. And my range, what can y not equal? My y cannot equal 2. Notice my x equals 3 is my vertical asymptote, and y equals 2 is my horizontal asymptote. All right, you guys will have fun with this next example. All right, so say we have a function written like this, in this form, ax plus b over cx plus d, and we want to change it into a simple form from day 1 to where we could easily pull out that vertical and horizontal asymptote. Not quite sure what that is. All right, so remember back to first semester. I know you guys all love long division of polynomials. We're going to go back to it. Luckily for you, these aren't that bad. They're not nearly as long and extenuous as the other ones were, but we do have to go back to it. Okay, now one thing I want to remember, or I want you guys to remember, is anytime we have a fraction, this is the same thing as saying 3x plus 5 divided by x plus 1. Okay, just like 1/2 is the same thing as 1 divided by 2. 1/5 is the same thing as 1 divided by 5. Fraction is just divided by sign. So we're going to do long division with this. So I can say 3, let's start over. That was kind of weird. All right, 3x plus 5 divided by x plus 1. Okay, now remember from first semester when we did this, all we worried about was the first term here and the first term here. Okay, so it's x and x. So what can we multiply x plus 1 by to get rid of this 3x? Well, we can multiply it by 3. Because when we multiply it by 3, I'm going to take 3 times x plus 1. So 3 times x plus 1 is going to equal 3x plus 3. So I'd say 3x plus 3 here. Now what I do with that is I would subtract them. Okay, and when I subtract them, I have to subtract everything in here. So this plus now changes to a minus. So 3x minus 3x, 0. Those go away. I don't even need the 0. And then 5 minus 3 is just a positive 2. So when we would write this, I would write it as, well, that would equal 3 plus 2 over x plus 1. Now I can change this a little bit to 2 over x plus 1 equals 3. Now notice this. Ooh, this is a plus. Notice this and this are the same form. Okay, so now we can go back to what we did during day 1, where this would tell us that we're going up 3, and this would tell us we're going left 1. So when it says describe the graph as a transformation of f of x is a over x, well, in this case, our a is 2. So all I would say is this graph is 1 up, or 3 up, sorry, and 1 left of f of x equals 2 over x. Okay, if I wanted to graph it, I'm not going to spend a lot of time here. There's my graph. My y asymptote, I'm going up 3, 1, 2, 3. So here, this is y equals 3. I'm going left 1. So x equals 1. So my graph would look something like this. You guys can put it in your calculator or make a table, whatever, to do a little more. So once again, asymptote, asymptote, the rest is easy. Most of you will struggle with the long division of polynomials. Luckily, these will all be short and simple. All right, last example for this lesson. We have a word problem. I know you guys love it. Let me see if I can, nope, give myself more room, I can't. All right, so a 3D printer builds layers of materials to make three-dimensional models. Each deposited layer bonds to the next layer below it. Company decides to make a small display models of engine components using a 3D printer. That's all, we don't really care. All right, here comes what we need. The printer costs $1,000. Okay, so our startup before you make anything, it's $1,000. And then the material for each model is $50. So every model we make, it costs us another $50. So if we make one model, our total cost is $1,050. So if I make 2 models, the cost is $1,100. Okay, so how many models must be printed for the average cost per model to fall to $90? Hold on, let me see if I can do something real quick. Give myself more room here. There we go. All right, there we go. All right, so let's put this in words first. So the average cost per model, oh, pin, dang it. All right, average cost per model. So I'm going to say average cost is going to equal, well, just how much we've spent over how many we've sold. So how much is spent? So we have to start with the $1,000 plus it costs $50 for each model sold. So that would be our cost. Now, if we want our average cost, it would be our total cost divided by the number sold. All right, so that's our equation here. Okay, so let's look at the question. Estimate how many models must be printed for the average cost per model to fall to $90. So we know that the average cost, we want to know when it's going to be 90. So I could say 90 equals 1,000 plus 50m over m. Okay, and then I want to solve for m. So first thing I want to do, get rid of the fraction, so multiply both sides by m. So that and that'll go away. So 90m equals 1,000 plus 50m minus 50m minus 50m. I get 40m equals 1,000 divided by 40 divided by 40. So 1,000 divided by 40 is 25. So when I sell 25 models, the average cost would be $90. All right, so if I look at this graph, if I just want to look at the right axis, I don't care about the other, I can't have negative models in this. It goes something like this. Okay, if I plug that in. So what that means is the more I sell, that's my X value, what happens to the average price? It goes down. So the more I sell, the less the average price per model is. The more I sell, the less the average price per model is. Okay, that's it for this lesson. Please make sure you do your homework on Big Ideas Math. It is due Thursday night, midnight. And as always, please shoot me an email if you're having problems or stuck on something. Don't ever feel like you're alone. Have a good one, guys.